starts. Okay, so it's starting now. And then I watched the video. I don't know if it necessarily pertains to this lesson, but I think it pertains to the other lesson for the week. And he mentioned something called the applet. Did you guys watch that, or do you know what I'm talking about?
I haven't watched it yet.
I haven't watched it yet.
So he said something about you go to the textbook, in the search bar you can type applet, or you can go to the resources, and under resources you'll see something called an applet. It's something that you will be using, I think, at the end of this week. So you either need to watch his call, it's like less than 30 minutes long, or if you don't understand it, you should watch his call. And then he also said that some of the questions are going to ask you to use the 68%, 95%, and 99.7% thing instead of the applet. And he said, pay close attention to that, because you're either using the little applet device, which is more accurate, or you're going to use the 68, 95, 99.7% rule.
Okay.
And it doesn't mean anything to me yet because I haven't looked at that lesson, but know that there's a difference, and you need to definitely use whatever he tells us to use when you do it. And watch his little video. Well, I assume the videos we're going to watch are going to be pretty clear, but if they're not, then you might want to look at that. All right, so on the quiz, there's 13 questions, 4 of us, so like 3 or so questions each. Oh, and then we have these, so it'll probably just be 3 questions. Let's see. We completed the assignment. We actively participated in the group. True. Okay, going down here. All right. Who would like to start with the first few?
I'll start.
Okay, go right ahead.
It says, use the following information to answer the next 3 problems. Human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. The question is, the blood types and the proportions given in the table above define a probability distribution. I'm going to say yes. I actually took all those numbers and added them up, and they all add up to the number 1 that we do want.
Okay. Okay. And let me go to all my notes from what that even meant, because I don't even remember what probability distribution meant. But I guess that's the second.
The 3 rules is the probability distribution.
Yeah. Okay.
Then, which I have a really hard time defining, like, in my own eloquent words. I'm not very eloquent when the textbook is. I try and type it out in my own words, and I'm like, it just sounds ridiculous, but.
All right, I'll do the next one, I guess. What is the probability that a randomly selected person in the U.S. has the O blood type? So let me pull that up. So O is 0.45, so it's 45 over 100, which we probably just have to do it in let's divide it. 45, I don't even have my calculator ready. Let me grab that.
It should just be 0.45.
I think, I think you just put 0.45. So yeah, at the top, all your answers in decimal.
Okay.
Yeah, I agree. Just leave it as 0.45. Yeah.
Yeah. So 0.45. I didn't see it there.
Okay. So no.
This is where the reverse comes in.
Okay. So what is the probability that a randomly selected person will not have the type O blood? So
you can just do 1 minus the 0.45.
Yeah. So 0.55.
55 is correct.
Okay.
Use the following information to answer the next 2 questions. Caroline Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to the specimen derived from the bladder cancer patient. Tingle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples from the patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? So
7 bowls, yes?
Yeah.
So 1 divided by 7, is that what I'm doing?
Yeah,
One
so
step, one, yeah.
0.1428. You need to round it says to the 2 decimal places.
So
Yeah.
0.143?
Or 2. Oh,
One
no,
for
it's,
three?
wait, 3 decimals? Oh, you're right. Okay.
Yeah.
Yeah.
0.1143? Yeah.
Yeah.
Okay.
I have question 7. In the combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? The dog provides strong evidence that dogs can detect that bladder cancer. There is little evidence that dogs can detect bladder cancer.
Definitely the first one.
Right,
Yeah.
strong
I think-
evidence.
What do you, so the second one or the first one?
Wait, so.
First.
Oh, wait.
You're saying the first one.
It says it's very unlikely that a dog would be able to do this by random.
Yeah.
So I think that
there's
would be the
some
first one.
for that reason.
Sorry, I didn't understand. Which one did you, I thought it was second one because it's only 22 times.
It's only that's what I'm wondering, because it's only 22 times out of the 54 times, and if you take that, that works out to 0.407, which is only 40% of the time.
Yeah, but there's 7 pieces. So to get 40% of the time with 7 different.
That is a
voices.
pretty strong. You're right. Yeah, 40% really is a big number comparatively speaking. I mean, it's not like it was only 10% of the time. So yeah, let's go with this. Provide strong evidence that a dog can detect the bladder cancer.
That's what I would do.
Because, can you give me this? I don't understand why.
So
Essentially, here's what we're at. He detected it 22 out of the 54 times. And granted, that is only about 41% of the time, but 41% is really a high probability versus like only 10%. Because at 10%, it'd probably just only be chance. But they state in there, of course, that many times it probably isn't just chance. But I think they're really giving you the answer in that other sentence that they give you in that question.
Okay.
or maybe you say it's 45% of the time out of 49 dishes, or 7 dishes times 7, however many trials there were. What did they say? 54 trials times.
54.
Like if we did it some other way, calculated it out, it would be a much higher percentage if you know that he's getting it 40% of the time out of that many dishes. I don't know how to do that math, and that confused me.
Oh, but I got him. Okay. They haven't said. Okay.
All right, am I up?
Yeah, I think so.
Okay. M&Ms. They're small chocolate candies. The M&M website previously indicated that in the U.S., the distribution of colors in a bag of plain M&Ms is given in the following table, and green is crossed off for some reason. Huh. Maybe they changed it to blue.
To
Maybe
figure it out.
In
They want us to
addition
figure
to
it
a
out.
bag of plain M&Ms, what's the probability of drawing a red-colored candy? It's 13. Wait, let's add up and make sure they all add up to 100 first, just for fun. 13 plus 14. I just want to make sure they add up.
They want to add up because the green is
Plus 20.
missing.
Yeah, so the green is missing.
The green is 0.16, if like my calculations are correct. If they want to double check that calculation.
It is 0.16. So why do you think it's crossed out? It's confusing to me. But
it's question 9.
Because what?
Question 9 is asking.
Asked us to figure it out.
Oh, they're going to have us figure it out. That's why. All right. At any rate, the red color is 13%. So what's the, wait, what was the question? What's the probability? So we just say 0.13.
It's a 0.13, yeah, that's in the table. So really just making sure we can read the table right there. And that's the question.
So then it's, what is the probability that a randomly selected candy is green? So it's 0.16.
Yeah. And then what is the probability that a randomly selected candy is not green? So what is that, 0.84?
4? Yeah.
Okay.
This was green. Yep, 0.84. 4.
time up. The ACT scores of students admitted to a medium-sized public university in the Western United States were taken from CastXM.com. The following summary statistics were calculated. Half of the observations are less than or equal to what number?
What?
Wait, so
Is the mean or the median?
Because the mean is the
Oh, it's the
average.
median. You have to look
This
at the
is
median. Yeah. So half of them would,
24
yeah.
are less than or equal to what number? Less than or equal to 24.
Okay. The next
Everyone got
one's
that?
the,
Everyone understanding that?
I do. Based on your information on the table above, the top 25% of students scored above what number? And is that Q3?
That should be Q3.
So 27.
wait, the top.
No, the 25% is not Q1.
I
No,
think the lowest,
Well, because
the
it's
lowest is the
Q1.
highest. So
Sorry,
Q1 would be one of the lowest scores.
I didn't get it. I thought 21% is Q1. Because the
They're
median
They're
is,
asking for the top
It's asking for the
25%.
top scores, and so since
the
data
top.
goes from smallest
yeah.
to biggest, Q3 would be the top.
Yeah, sorry,
highest.
I only read 24. Yeah, you're right. So that's Q3, 27?
Correct.
Yep.
Okay.
Which one of the following statements is not one of the 3 rules of probability?
Okay, we know it's the second one. We know.
The third one, if the probability is high, then the probability is positive.
The
That one.
probability is
If the probability is low, then the probability is negative. Number 3?
Yeah, we're not allowed to have a negative probability.
Yeah.
I'm moving with that. If the probability is high,
Yeah.
then the probability is positive, and the probability is
That
low, then
one.
the probability is negative. We cannot have a negative probability.
Okay.
All right. I want to make sure I saved them all right. 27, 24, 84, 16.
I went ahead and submitted the quiz. We got 100 out of percent, 15 out of 50. Way to go, ladies.
Oh.
Sweet.
Got everything down right.
I know, I hate that you have to go back and save all these. They ask you so many times. Did you save your answers? Are you ready to submit the quiz? Are you sure? Are you sure?
Yes.
Especially I'm taking this one class and we have to do an honor quiz before we do 3 assignments every week. So it's 7 questions, the same questions over and over again. I promise I won't share information and this and that, and then I have to run time. Yes, there's so many clicks for just this silly quiz sometimes.
I'm taking the same class. I
Oh,
promise.
are you? How funny.
I will always I'm sure I promise. I will never do it. Ah, yes. I don't like that.
All right. That went through. Good. All right, guys. So I guess we'll see you guys in a couple days. Email if you have questions.
Okay.
Yeah, I'm kind of nervous about this applet thing, but hopefully they've been really good about explaining things, so hopefully we'll all figure it out.
It's kind of weird, and you have to, the most important thing the teacher said is to highlight the section that you're interested in finding out the answer. So there's a graph that goes up and down, and you have, it's broken into like 3 sections. You can highlight this side, or 2 sides, or just the center side, the center section.
Okay, yeah, I've learned somewhat about that, so I kind of know a little bit.
You usually highlight the one all the way to the right. That's what I was confused by when he was doing it. And I
I
think
don't know what he's talking about highlighting it, but I know like what graph you're talking about.
okay, so we'll ask each other if we have questions between now and then.
Yeah. Yeah.
All right,
I'll read it and find out.
Okay.
thank you, and I'll see you in a couple of days.
Okay.
Thank you.
All right. See you
Bye.
Thursday. Bye.